All right, folks, it's Bass Action back in action here. In this video, I want to go through some additional examples for law of sines. These are going to help you with the practice problems and the practice sets that you will see on Canvas. So let's just jump into our first two basic examples where we're asked to solve a triangle. A reminder, solve the triangle means find all the missing parts. So the first thing that we would want to do on this example A is to find the missing angle of 35. Now we want to go through the mental thought process of how we would solve this triangle, and we would first recognize that it's not a right triangle. So none of our right triangle strategies are going to work, including SOHCAHTOA. The next thing that we're going to look at is, do we have a link? That link being the measure of a side and the measure of the angle across from it. And of course, we can see that we do have that link. If we have that link, then we can go ahead and we can set up our law of sines. The measure of a side divided by the sine of the angle across from it will equal the measure of any other side. So for example, this side A can be divided by the sine of the angle across from that, which is 25. Now, if you do the algebra, I'm not going to go through that in this video because I've gone through that algebra in the other video. If you go through the algebra for this, either stopping here and typing in your calculator or writing it out, you should be able to get an A value of approximately 5.5. We can repeat that process since we were asked to solve the triangle to find the measure of side B. And what we will do is we will use this exact same link. You'll use the same link throughout the entire problem. We'll use that same link, 7.5 divided by the sine of 35. And that's going to equal our side B divided by the sine of its angle. And if you did that algebra, you will get your B value of approximately 11.3. Now, each problem will specify how it wants to be rounded. If it doesn't, we're going to follow the rounding instructions up here at the top. Okay, let's look at our next problem. On this problem, again, asked to solve the triangle, we can't find any additional angles. So we, of course, have no idea what kind of triangle it is, but we do well, actually, that's not true. We do know this one's obtuse, so we know this is going to be obtuse. It's not right, but we can see that we have this link from the very beginning. So we're going to take that measure of that side, 32, divided by the sine of 120, and that's going to be equal to our 7.5. And now we're going to divide by the sine of the angle across from it, but this time we don't know the angle. So remember, when you set this up, when you do this whole cross multiplication, what you will get to type in your calculator is you will have the sine of C, and you're going to have 7.5, and you're going to have the sine of 120, and that's all going to be divided by 32. This is going to give you a decimal. You will need to do your inverse sine to actually get the measure of angle C to be approximately 12 degrees. I'm going to put that angle 12 back into my picture because that's going to help me better visualize how to find this last angle, and that's just going to be that they all add up to 180, so that'll be 48. Now remember, I mentioned in the last problem we used the same link through the entire problem, so we're just going to use that same link again, 32 divided by the sine of 120, and the last thing we're looking for is this side A, and that's going to be divided by the sine of 48. When you work through that algebra, that's going to give you an A value of 27.5. Okay, the next thing I want to look at is a word problem here. This one's going to be a little different than the one that we had the other day. So the other day, we knew the measure of this whole length. We had some different angles, and we were looking at two separate right triangles. We worked with this right triangle and we worked with this right triangle because we had enough information to actually work with the right triangles. On this particular problem, what I want to call your attention to is that this 10 is only for this small segment here. So we don't have a complete side in any of the right triangles. So what we're going to do instead is this is going to give us a chance to use our law of sines. We can look at this triangle right here. Okay, it's not a right triangle, but if we fill in some missing angles, what we can find is this angle right here is going to be supplementary, so we can recognize that that angle is going to be 125 degrees. Now, if this is 48 and this is 125, we can fill in the top angle up here of 7 degrees. Now, I'm writing them outside because the picture's kind of tiny. What this is going to allow us to do then is recognize that although it's not a right triangle, we know the measure of an angle and the measure of the side across from it. So we have that wonderful link that we want to be able to use. So our side is 10, the sine of our angle is going to be sine of 7. Now, we're going to pick either side to find. It doesn't matter, but I'll be honest, I think that this piece right here is the easier side to find. So now we're going to take our side x, and the angle across from it is 48, and that'll be sine 48. So if you do this algebra, you're going to get a value in your calculator of approximately 61.0. Now, don't clear that number from your calculator quite yet. You'll be able to get a much nicer answer if you don't. The next thing that I'm going to do is now I'm going to look at this right triangle. And now that we're back to a right triangle, we can use our SOHCAHTOA and we can say, hey, we know this measure here because we have it right here, and we want this measure. So we have an opposite and a hypotenuse. So we can just say the sine of 55 degrees, just pulling it from right there, is going to equal that h that we want divided by this x value. Now, I'm not going to write it in quite yet. Remember, if we cross multiply this, we're going to get an h is equal to x times the sine of 55. So if you can take that number that's already in your calculator and just press times sine 55, you will get a height of approximately 50.0 meters. Okay. The next one I'm going to look at, this one was discussed in the video for law of sines. We set it up, but we didn't actually solve it. So I'm going to redraw that picture. We've got an airplane spotted by two people, and they're facing each other. Them facing each other is an important detail. Okay, so they're going to face each other, and they're 1,500 feet apart. Now, Aaron is going to be on the east side. Wendy's going to be on the west side. Aaron's angle of elevation is 32. Wendy's angle of elevation is 27. Again, we already did this picture in the other video. What we want to be able to do is find the height of this triangle here because our airplane is up here. We want to find this height. We can't quite do that yet, so what we're going to do first is we're going to fill in our missing angle up here of 151. Again, all the angles just add to 180. If we fill that in, we can see that we have a link. So although the triangle is not a right triangle, we do have a link. So we can say that our distance of 1,500 divided by the sine of 121. I just realized I wrote 151 there. Sorry if that was confusing. This is actually supposed to be a 121. And this is supposed to be, this is probably going to lock up on me in just a second here. It never likes when I use my eraser. We're going to let that go through. Okay, sorry about that delay. I'm not really sure how that turns out on your side. 121. Okay, now 1,500 over our 121. We're going to find, just like before, it doesn't really matter which side you choose to find. I'm going to choose to find this one. There's truly no difference. I'm going to put an x, and I'm going to say sine 27. And again, go through your algebra. That's going to give you an x value for that side of the triangle of 927.3. Now, once you've done that, we're going to use this number just like we did before. We're going to draw in the height of the triangle. We're going to look now at this nice right triangle here. And we're just going to do our good old SOHCAHTOA. So where this is going to be our angle, we want this height. We have this hypotenuse. So we're going to say the sine of 32 is equal to the height that we're looking to find. divided by the side that we already have. That's going to give us our height is x times the sine of 32. Now, you already know x, it's right here. So take the number in your calculator and just hit times sine 32, and you will get the height of the airplane of 421.0 feet. All right, the last thing I want to do is just an important reminder, because students always forget this formula. If they ask you to find the area of a triangle, quick, make a little picture of that triangle. Okay, little ABC, doesn't even have to be pretty, doesn't have to be to scale, doesn't matter. Side A is 15, side C is 21, and angle B is 17 degrees. I want this to pop out to you immediately as a side angle side pattern. So this problem shouldn't take more than about 30 seconds, because you can do 1/2 21 times 15 times the sine of 17. Just re-enter that formula, and you will get an area for the triangle of 46.0 units squared. Now it's approximate. So don't spend a bunch of time redeveloping a formula that we already went through the exercise of doing in the previous video.